Can you see my screen? Give me a thumbs up. Okay, thank you, Willa. Now, recognizing experimental variables and conditions. So we covered already last lesson. Okay, independent variable that is manipulated and changed by the experimenter. So for example, I'm the one carrying out the experiment. I want to explore, okay, whether, the amount of light affects the rate of photosynthesis in a plant. So the variable that I change is actually the amount of light. Right now. Then if I want to take the same experiment, okay, I want to measure something in order for me to know whether there's more photosynthesis, okay, happening or taking place, I need to measure something. Right now, I cannot ask the plant, do you photosynthesize more? Isn't it? Okay, so I can only do certain form of measurement. And one of it is to actually collect the amount of gas that is being produced. I think you have already gone through that as well, okay, in school. So the answer for that will definitely be, okay, to measure the amount of gas produced during photosynthesis. Okay, so if I have more light, then of course, more oxygen gas will be produced. So that is telling me that the greater amount of light there is, okay, the higher the rate of photosynthesis, right? So control variable that is left unchanged during the experiment. Okay, so I can say things like the type of plant that I'm using, maybe the number of leaves on the plant. Yeah, so all these got to stay the same. So if you want to try to link to what you have learned in school, because last week, some of you told me instead of independent variable, you have actually heard of the term change variable, right? Okay, rather than independent is change. Then for the dependent variable, in school, your teacher used the term measured variable, okay? Then, of course, a controlled variable, you can also call it fixed variable. Fixed variable means you do not change it, you keep it the same. All right, like just now I mentioned the type of plants, the number of leaves on the plant. So you are supposed to answer some questions, right? This is the first one that you did on your own. Okay, 3 plants PQR were placed in identical jars as shown below. Each jar was filled with 200 cm³ of water and a layer of oil over the water. Yeah. Okay, so the table below shows the amount of water left in the jar after 3 days. Okay, Ziying, I can see your screen. So interesting. Yeah, so this is how you are viewing the lesson. I see. Okay, thank you. Right, so the table below shows the amount of water left in the jar after 3 days. So if you take a look, plant PQR, the number of leaves on each plant is indicated. Volume of water left is also shown. So in this case, what is the independent variable? Have you all done this? Have you all done the worksheet already? Shen, did you do it? You did, I hope you really did, all of you. Okay, so the first one, independent variable, is something that we change, and that's the number of leaves, right? So the number of leaves will determine something, the volume of water that is taken in by the plant. So we measure the volume, actually the volume of water that we are measuring. Okay, over here it says left behind, but the amount of water that is left behind is also indicative of how much water was actually taken in, isn't it? Yeah, this is something that we can find out, right? Easily. Okay. Next, controlled variable will be the amount of water at the start of the experiment. It is stated here, 200 cm³, the type of plant used. Okay, and then also the layer of oil must be present in each of the experiment. All right, so for the setup P, setup Q, setup R, you have the same layer of oil there. Yes, Ziying, please go. So how does the independent variable affect the dependent variable? So our independent variable is about the number of leaves on the plant, right? When there are more leaves on each plant, the volume of water taken in by the plant is higher. Can see that, right? You have more leaves, more water taken in because you are left with lesser water at the end. Any question? All good? Yeah. Cheryl set up the experiment as shown below. She tried to lift up 6 paper clips from the same height using 3 different magnets. Okay, 3 different magnets. So you can see the difference in the magnet, right? Okay, one is maybe average in terms of length. Okay, one is a lot shorter, one is a lot longer. Okay, so we can talk about the length of magnet. We can also talk about the size of the magnet. So they are different. So that's our change variable. What did we measure? I hope you have gotten the same answer as me. What we measure is actually the number of paper clips picked up by the magnet. Okay, so what must stay the same? Distance the magnets are from the paper clips. Number of paper clips on the table at the start of the experiment. Okay, some students will even say how the paper clips are being arranged. They must be arranged in the same manner for each of the magnet to attract. Yeah, because you cannot have, let's say, cases where you have the magnets stacking up. So the one at the top show will be attracted by the magnet, right? Right not? Then another experiment, then you have the magnets arranged this way. Then another experiment, your magnets is like no, 6 only. So like that. Okay, so if you want the arrangement of the paper clips to be in a certain manner, that can also count. Because if you are going to stack on top of each other, right? Stack the paper clips on top of each other, the one right at the top is very, very close to the magnet. Agree or not? So it can be easily attracted. So these are some of the things that we can think about. Okay. Then how does the independent variable affect the dependent variable? Now, the size of magnet affects the number of paper clips picked up by the magnet. It's very clear already. Magnet A, 4 pieces attracted. Oh, sorry. Let me change this. Just one. It shouldn't be okay, you see, because this is the biggest magnet, but it attracted only 3 paper clip, right? So it should be the size of the magnet does not. Okay, because the biggest one did not attract more paper clips. Okay, so the size of the magnet does not affect the number of paper clips picked up by the magnet. Do you all get this? If you didn't, copy it down quickly. All right. So this one is because magnet C is the largest. But picked up only 3 clips. You all can see that, right? Okay, let me go on to the next one. Jacob conducted an experiment to show how exposed surface area of towels affect the rate of evaporation of water. All right, he used 4 identical towels of the same material and thickness, but folded them into different sizes as shown below. Okay, so he soaked the towels in water. After that, he measured the mass of the towel. So at the beginning, all the towels weigh the same, 200 grams. That means they contain the same amount of water. Okay, so after that, he put all of that under the sun, right? After 30 minutes, he measured the mass of each towel again. And it seems like, towel A, 92 grams left. Then towel B, 158 grams left. Towel C, 118 grams left. And then after that, towel D is 180 grams. So you see over here, the independent variable already mentioned in the question, the towel were being folded, right? So the exposed surface area is what we change now. Okay, they are all the same size. All right, they are all the same size. Okay, what is different here? Okay, what is different here? You have to know. Hey, Celestine, you're here today. Okay, yesterday was your sister. Looks like the same person. Are y'all twins? No, but you have different names. Would you like to let me know? Because suddenly I look at you and say, hey, how come I seem to have seen you earlier?
She's 1 year younger than me.
But both of you look the same. Is that right? Not the same? Oh no, why am I like seeing both of you having the same look? It's okay. Yeah. Oh, okay, ask your sister to come in. Let me take a look. I was shocked because yesterday her sister logged in with her name. Then she changed it. So I saw the name Calista. And now, today she logged in as Calista. She changed to Celestine. Yeah. Same look. You see, exactly the same look. Okay, never mind. Let's continue. I just got a bit surprised. Sorry, everyone. Okay, let's continue. Now, so the towel, okay, is being exposed in terms of their surface area differently because of them being folded. So imagine if I have, let's say, the towels, all of them are actually in this squarish dimension. So all of them same size, but one of them I folded this way and then I hang it. Okay, so I hang it on the wooden pole. Okay, another one, I folded one time and another time I hang it this way. They all started off with the same size. Okay, same size, same material, all right, and they have same amount of water in them. Then another towel, okay, I fold one time, two times, then I fold it another time and hang it this way. Okay, and then imagine the next towel that I have, I folded even more. Okay, you understand? So this is how they are trying to tell you the amount of exposed surface area gets smaller and smaller with each fold. So if I have something like this, one towel folded this way, you just imagine your clothes. Do you hang your clothes by folding first and hang it on the rod or wooden pole? No, you have not seen your mommy or your helper do that, right? Okay, if you have been helping to hang clothes, you're not going to fold it and then hang it hoping it will dry fast, right? It will take a long time because of the exposed surface area. It's very little now. The lesser the exposed surface area, the longer time it will take for the water to evaporate. Okay, so it's stated here already. Yeah? So rate of evaporation is what we are measuring. Okay, some people will say that it's the mass of the tower. Okay, it's the mass of the tower. So that is actually the measured variable. Then control variable, okay, material of towel must be the same, thickness of the towel must be the same, starting mass must be the same, okay, maybe even the size of towels must be the same. Okay, because original size must be the same. The way it's folded will be different. So the greater the exposed surface area of the towel, the faster the rate of evaporation. You can see all this, you can see the relationship. Question 4. Okay, now Jason conducted an experiment using 2 containers of identical size, okay, made of identical material but with different thickness. So if I were to make it clearer to you, this is actually thicker. So I'm going to shade such that it looks thicker, even though on the outside they look exactly like it's the same size, right? Okay, but this container is made of thicker material. Okay. All right. So he poured 50 cm of water into each container. The thermometer was then placed in each of them. So the water in the 2 containers were then heated to boiling point. Okay. The table shows the time taken for the water to reach the boiling point. Okay. So first one, this one take 15 minutes. The other one took 10 minutes.